The primary challenge in V2 to FHIR transformation is managing the implicit context of V2 segments within the explicit resource graph of FHIR. A typical ORM 01 message requires decomposition into at least service request, patient, practitioner, and potentially location resources. V2 repeating segments, like multiple OBX groups, must be instantiated as separate FHIR resources, linked via bundle references. We must first establish a robust V2 parser, preferably one that handles custom Z segments and version variances, before attempting resource creation. The goal is semantic preservation, ensuring that the V2 message structure, which often implies temporal or hierarchical relationships, is accurately reflected using FHIR references and contained resources where appropriate. Parsing V2 is non-trivial due to variable delimiters and segment repetition. Utilize a library like Happy or similar robust parsers to handle the message structure definition. Focus specifically on the segment group structure, particularly in ORU R01 messages, where the observation request segment OBR repeats, each containing multiple observation segments OBX. Before mapping, normalize the V2 structure into a predictable intermediate object model. This intermediate model simplifies handling optionality and ensures that fields like MSH10, the message control identifier, and MSH7, the date time of message, are immediately extracted for use in the FHIR bundle metadata and identifier tracking. All V2 transformations result in a FHIR bundle resource. For real-time message exchange, use the bundle type message. For bulk data ingestion, use the transaction type. Each resource within the bundle must be wrapped in an entry object. Crucially, assign a unique fullUrl to every entry, typically a uniform resource identifier using the earn UUID scheme, even if the resource is not yet persisted. This fullUrl acts as the internal reference target for other resources within the same bundle, replacing the implicit V2 pointers. The bundle metadata must include the original V2 message identifier for traceability. Mapping the patient identification segment PID is foundational. PID3 contains the patient identifiers. Each repeating instance must map to a separate FHIR identifier element within the patient resource. Standardize the assigning authority, mapping the V2 component PID 3.4 to a canonical uniform resource identifier system, often based on the organization's object identifier. PID 5 maps to the human name element, requiring careful handling of components like family name and given names. Ensure that administrative gender PID 8 is mapped using the FHIR code system, translating V2 codes like F, M, O to female, male, and other, respectively. The order control segment ORC and observation request segment OBR define the procedure or service. An ORM message typically maps to a service request resource. The ORC5 order status must be translated precisely to the service request status codes. For example, V2 status A for accepted maps to active. The OBR segment details the requested procedure. If the V2 message is a result, ORU, the OBR often maps to a procedure or diagnostic report resource, depending on the context. Use the OBR4 universal service identifier to populate the service request code element, ensuring proper coding system translation, such as LINC or SNOMED CT. The observation segment OBX is the core data payload. OBX3 maps to the observation code. OBX2 defines the data type, dictating which FHIR value element to use, value quantity, value string, or value cognitive code. For quantitative results, OBX6 provides the units. These units must be converted to the Unified Code for Units of Measure, UCUM standard for FHIR compliance. If the result is abnormal, OBX8 provides the abnormal flags, which map directly to the observation interpretation element using standard FHIR codes like A for abnormal. Pay attention to the datetime fields OBX14 and OBX19 for accurate temporal context. The critical step is establishing the resource graph using internal references. After creating the patient, practitioner, and observation resources, link them within the bundle. For example, the observation resource subject element must reference the patient resource using its assigned fullUrl. This is done by setting the reference value to the earn UUID generated earlier. Similarly, the observation performer element references the practitioner resource. Ensure that the reference type is correctly specified, preventing downstream system errors during persistence. All references must be relative to the bundle itself, not external uniform resource locators. Implement strict validation against strict FHIR profiles, such as US Core, immediately after resource creation. Missing required V2 fields like a mandatory identifier in PID3 must trigger a specific error response. This is often an application-level reject ACK message in the V2 world, or an operation outcome resource within the FHIR response bundle. Use the operation outcome resource to detail validation failures, specifying the resource path and the constraint violated. This ensures data quality before persistence and provides actionable feedback to the sending system, preventing silent data loss or corruption. Choose the appropriate mapping engine. For high-throughput environments, consider custom Java or TypeScript services utilizing FHIR software development kits. For lower volume or rapid prototyping, integration engines like MirthConnect or Rhapsody offer visual mapping tools. The final step involves deciding whether the FHIR bundle is persisted transactionally, meaning all resources are saved simultaneously, or if the resources are extracted and stored individually, relying on the receiving system to manage the relationships. Always log the original V2 message alongside the generated FHIR bundle for auditing and debugging purposes.